Hello everyone, in this video we will learn about average speed, average velocity and acceleration. So what is average speed? Average speed is equal to distance traveled over the time taken. So the total distance over the total time equals to average speed. So we can use abbreviation. We know S is speed equals distance over time, and the average speed is equal to the total distance over the total time. And what is average velocity? Average velocity is equal to displacement over time. So we can use V with a bar for average velocity. So a bar or an arrow on top of V to show that V is a vector. It has direction, which equals to displacement, which can be written as x or delta x over the time taken, which is delta t or t total. So speed is a scalar quantity. It doesn't have direction. So speed is scalar quantity. It has magnitude only. And velocity is a vector quantity. It has magnitude and direction. And now let's look at the units. We know distance traveled could be in meters or kilometers. So if the distance is in meters, the time taken is in seconds, then the unit of speed would be meters per second. And displacement is also in meters. Time taken is in seconds. And the average velocity would be in meters per second. Okay, so if the speed is given to you and the time is given and you want to find the distance, then the distance equals speed multiplied by the time. Okay, so here we can write as distance equals speed times the time. And the time, if you want to find the time taken, given the value of distance and speed, then the time is equal to distance over the speed. Okay, so let's look at some examples. So here we have a question. A car travels 10 meters north. As we can see here, the car travels 10 meters north. So this is the starting point. Okay, and you are moving upwards 10 meters in 3.5 seconds, then 5 meters south in 1.5 seconds. What is the displacement? So as we know, displacement is a straight line distance from the start to the end, from the tail of the first vector to the head of the last vector. So in this case, displacement, this gap is equal to 10 minus 5. And 10 minus 5 is equal to 5 meters. And from this vector diagram, we can tell that displacement is upwards. So the direction is north. Question B, what distance does it travel during the journey? So what is the total distance traveled by the car? So the total distance would be 10 meters plus 5 meters, which equals to 15 meters. Question C, what is the average velocity of the car in meters per second? We know the average velocity is equal to displacement over time. So displacement is equal to 5 meters, and we know the direction of displacement is north, and the time taken is 5 seconds. 3.5 seconds plus 1.5 seconds equals to 5 seconds. And the average velocity in this case equals 1 meters per second, and the direction of the velocity is north. Question D, what is the average speed of the car? So we know the average speed is equal to the total distance over the total time. The total distance is 15 meters and the total time is 5 seconds. And therefore, if the distance is in meters and the time is in seconds, then the answer must be in meters per second. So in this case, the speed average or the average speed equals 3 meters per second. All right, so what is acceleration? Imagine you are driving and you are increasing your velocity from 0 kilometers per hour to 60 kilometers per hour. In this case, because the velocity is changing, we can find the acceleration, the average acceleration. So the average acceleration equals final velocity minus initial velocity. So this equals to change in velocity over the time taken. So the average acceleration equals change in velocity, which is final velocity minus initial velocity over the time taken. And using abbreviation, so we use A for acceleration equals V for final velocity minus V naught for initial velocity over T or delta T for the time taken. But the question doesn't always give you V, V naught, and T to find A. Maybe the question will give you the value of A and they ask you to find the value of V or V naught or T. So we need to know how to make V the subject, how to make V naught the subject, and how to make T the subject. So step one, we can just get rid of the fraction by multiplying both sides by T or delta T. So I will just use T for now. So A times T is equal to V minus V naught. And now, what is V? Let's make V the subject. So we will just use this to make V the subject. So in this case, V is equal to V naught plus AT. And V naught is equal to, so move minus V naught to the other side, it becomes plus V naught. And on the right hand side, we have V. And now you want to move AT to the right hand side and we get minus AT. All right, and what is T? T is equal to V minus V naught over A. So now let's look at question one. Question one is, a car accelerating uniformly reaches a speed of 30 meters per second from rest. So in this case, this is the final velocity. The final speed is 30 meters per second from rest. So the initial velocity is 0, V naught is 0, and the time taken is 2 minutes. So we need to convert 2 minutes to seconds. Okay, let's find the value of the change in velocity. So the change in velocity equals V minus V naught. So the final velocity is equal to 30 minus the initial velocity, which is 0 from rest. That means the initial velocity is 0 from rest. And therefore, the change in velocity is equal to 30 meters per second. So please remember, change in velocity equals final velocity minus initial velocity. And the acceleration equals V minus V naught over T. So we already calculated V minus V naught, which is 30, over the time taken. And we said the time taken is equal to 2 times 60, because we have 60 seconds in 1 minute, and we get 120 seconds. Okay, so now 30 over the time taken, 30 over 120, this equals to a quarter, 1 over 4, and 1 over 4 is 0.25 meters per second squared. So, if the velocity is increasing, then the acceleration is positive. And if the velocity is reducing, so imagine you are slowing down from 50 meters per second to 0, then we are decelerating. Then the value of A must be negative. And don't forget, acceleration is a vector quantity. It has direction. But in this case, we don't know where the car is traveling, in which direction. If the car is traveling to the right, then the car will accelerate to the right. If the car is traveling to the left, then the acceleration will be to the left. So this value is in the same direction as motion.